Okay, first learning objective for this video is to draw basic probability tree diagrams and then find probability and expected number of outcomes. So there are 4 yellow and 5 red balls in a bag. A ball is picked and replaced. This word is really important. We're going to get on to when it is not replaced in the second video. But for now, it's really important that the ball is put back in after you have selected it. So after you've picked the first ball, you then put that back in, you then select a second ball, and we want to draw something called a tree diagram. So we know we have a first pick and our second pick. So they're going to go at the top of the tree diagram. On the first pick, we've got two options. We can either pick a yellow ball or a red ball. So we start off with two lines, one going to yellow and one going to red. So our two options that we have. For the second pick, if you've already picked yellow, you can still then, on your second pick yellow or red. So we then have a tree drawn from yellow, the second pick being yellow or red. And then if we had picked red on the first time, we can then still pick yellow or red on the second time. The probability for each of these go on the branches, so on the line. So the first one we're going to look at is, on our first pick, what is the probability of getting a yellow? So looking at the bag, we've got 4 yellows and 5 red. So the probability is 4 out of 9. So that goes on the yellow line. For the probability of red, we can either look back at the bag and think, right, we know that there's 5 red balls out of 9 in total, so the probability is going to be 5 out of 9. But also, these branches add up to 1. So if you know that the probability of yellow is 4 over 9, then the probability of red has to be 5 over 9. Due to the balls being replaced into the bag, it means that the probability for your second pick does not change. So imagine we've picked a yellow out of the bag, so we've picked this out, we then put it back in, and then we do our second pick. So now the probability of getting yellow is going to be exactly the same because we've replaced the ball. So the probability of yellow will be 4 over 9. And the probability of red will still be 5 over 9. This will be the same for these branches here. So you first pick out a red, the probability is 5 over 9. You put it back in, the probability of yellow will still be 4 over 9, and the probability of red will still be 5 over 9. So now we can use our probability tree to work out different combinations of outcomes. So for the first example, what is the probability of picking a yellow and another yellow? So picking 2 yellows. For this, we are looking at these top 2 branches. So I pick a yellow and then I pick another yellow. Making sure I write my notation correctly. So the probability of yellow and then yellow. So remembering our and or rules, I want the probability of picking a yellow and a yellow. So the and means multiply. So you always multiply along the branches. So the probability of yellow and yellow is 4 over 9 multiplied by 4 over 9. Remember that when you multiply fractions, you multiply the numerators and multiply the denominators. So 4 multiplied by 4 and 9 multiplied by 9. So you should get 16 over 81. We're now going to do the same for the probability of yellow and then red. So picking a yellow out first and then a red. So we multiply along the branches. So 4 over 9 multiplied by 5 over 9 should get 20 over 81. So now underneath, we're imagining that we picked out a red first and then a yellow. So what is the probability of picking a red and a yellow? Same thing, we multiply along the branches, so it's going to be 5 over 9 multiplied by 4 over 9. And finally, I'm going to do the probability of picking a red first and then a red on the second pick. So multiply along the branches, 5 over 9 multiplied by 5 over 9. So all of these probabilities at the end add up to 1. So every scenario adds up to 1. So now we've got our probability tree, we can start looking at what sort of questions we might be asked. First of all, we're going to look at the probability of getting 2 of the same colour. So you can either get yellow and yellow or red and red. So our different options are yellow and yellow or red and red. Because we've said or, it means we need to add these two probabilities. So 16 over 81, add 25 over 81. Remember, when you're adding fractions, if the denominators are the same, you can just add the numerators. Now we're going to look at the probability of getting 2 different colours. So the probability of getting yellow and red or red and yellow. So again, because it's or, we're going to add these two probabilities together. So 20 over 81, add 20 over 81, and you should get 40 over 81. Next, we're going to look at the probability of getting at least one red. So for this, there are 3 options. So yellow and red, or red and yellow, or red and red. So each of these have got a yellow ball being picked out. So because it's all for each of these, we're just going to add the 3 together. So 20 over 81, add 20 over 81, add 25 over 81. The other option is that you've got the probability of yellow and yellow being 16 over 81, and you know that all probabilities, so all of these add up to 1. So if you do 1 subtract 16 over 81, you'll get the same answer. And the last one, the probability of getting green. So obviously we've only got yellow and red balls in the bag, so the probability of getting green is going to be 0. Now you need to make sure that you write it as just 0 and not as a fraction. So if you wrote 0 over 81, you wouldn't get any marks. It's just 0. So hopefully you were able to draw this probability tree and find all of the outcomes at the end. If we want the probability of at least one green ball, we're going to add together these 3. So 27 over 144, add 27 over 144, add 9 over 144. The other way we could have done it is this one is left over. So we could have done 1 subtract 81 over 144 and you would have got the same answer. So this one's a little bit easier. Work out the probability that Tina takes 2 blue counters, so you're just looking at the bottom section of your tree diagram. So rather than work out all of the probabilities, I've just multiplied those two together. So 3 over 8 multiplied by 5 over 9, you should have got 15 over 72. Work out the probability that Hannah will win both games. So we're just conscious about the top section. So win-win is 0.6 multiplied by 0.7. Hopefully you got 0.42. So I'm not quite sure why it says work out the probability that green takes 2 green balls. I think it's meant to be Rachel. So work out the probability that Rachel takes 2 green balls. So it's the bottom row. So it's 6 over 10 multiplied by 5 over 8 should get 30 over 80. And then you could have simplified that to 3 over 8. Work out the probability that Jo will win both matches. So it's the top two. So 4 over 5 multiplied by 7 over 10. Work out the probability that Paul wears different coloured ties on Monday and Tuesday. So now we're not just looking at one section, we're looking at two. Because to wear 2 different coloured ties, he can wear red and black, or he can wear black and red. So the probability of getting red and black is 4 over 9 multiplied by 5 over 9. And then the other option is the probability of getting black and red. So that would be 5 over 9 multiplied by 4 over 9. So because we're saying he could wear red and black or black and red, we need to then add these two probabilities together. So 20 over 81, add 20 over 81. So this tree diagram was slightly different because you had 3 options, so win, draw or lose. but we still just want the probability of winning both games. So you just multiply along the branches, so 0.5 multiplied by 0.5. Work out the probability that Bradley's bus is late on at least one of these days. So there's two options, either that it's late on Saturday and on time on Sunday, or it's on time on Saturday and late on Sunday. So we need the section I've highlighted in yellow, so 0.2 multiplied by 0.8. We also need the blue section, so 0.8 multiplied by 0.2. And because these are two scenarios that could happen, it's this or this, then we add those two probabilities together.